Okay, this is a slightly more complicated example. I want to take a slightly soluble salt, CaC2O4, react it with a weak acid, and end up with CaF2 and another weak acid, oxalic acid. So this is calcium oxalate over here, hydrofluoric acid, and calcium fluoride. So calcium oxalate and calcium fluoride are what are called slightly soluble salts. And we went over that in freshman chemistry. They have something called a KSP, called the solubility product, which is an equilibrium constant. So I'm going to be very careful here. It's going to get complicated and it's going to take a page or two. I'm going to start with this one. I got to find a series of reactions that will add up to here, of which I know the K's. So I know I'm going to start here, CaC2O4, and let it react. This is a salt, slightly soluble salt, dissolving in water, and I get Ca plus 2 plus C2O4 minus 2, and I'll call that K1. I know this, it's the KSP of calcium oxalate. So what I'm doing is I'm building up the pieces. I've got CaC2O4 on this side. All right, now if I look at the fluoride, the calcium fluoride over here, right here, I'm going to run it backwards. It's another slightly soluble salt. So I go Ca plus 2 plus 2F minus in equilibrium with CaF2. I can do that. That's K2, and that's equal to 1 over the KSP of calcium fluoride. So this is working out pretty well. Now I have two pieces to the thing. All I got to do is get rid of the calcium. Well, hey, look, they cancel. Now I got to get rid of the oxalate and the fluoride. So let's try the oxalate. Okay, so I have something here that I need to think about, is the calcium or the oxalate here, and I want to produce oxalate on the reactant side. If I do that, if I can bring it over here somewhere on this side, it will cancel. And so I'll try that. Let's just take oxalate, C2O4 minus 2 plus water, and that gives us HC2O4 minus plus OH minus. I can get a K for that. K3 is equal to KB1 of the oxalate, which is equal to KW divided by Ka2 from the last one. You'll catch on, don't worry. Now that's fine. I can now cancel my oxalates, but now I have HC2O4, so I'll take that. HC2O4 minus plus water. That gives me H2C2O4 plus OH minus. I have a K4. K4 equal KB2 of HC2O4 minus, which is equal to KW over KA1 for HC2O4. All right, that's nice, because now these cancel, and I've got my H2C2O4 right here, which I needed, same as up here. So I'm picking them up. The only thing I need left is HF. Let's give it a try. I know a reaction for HF. That's really easy. HF plus H2O gives me H3O plus F minus. I know that K5 is equal to Ka of HF. And I'm going to do this twice. Times 2. That's the same as writing the reaction again. So for both of them, it's K5 and K5 again is KaHF. I have that reaction twice, so that's why I wrote the Ka over here. You could think about it and just square it. And then I look at this and say, oh, I know this reaction. 4 waters, 2 OHs, and 2 H3Os. So I write that reaction. That's the backwards water reaction. H3O plus OH minus yields 2 waters. Unfortunately, I got 4 because of this 2 out here, so just multiply that by 2. And I'll do K6 equal KW, and I have 2 of the reactions, so K6 again equal KW. All right, now I can add my reactions. Let's see. I got to cancel some more stuff. Let's cancel our waters. Here we go. In red, water, 1, 2, 3, 4. OHs, 1, 2. H3O plus, here it is. Okay, and do I have everything I need? 2 HFs, 2 F minuses, and I got to cancel that F minus. It shouldn't be in there. Oh yeah, up here I have F minus here and 2 F minus there, so they cancel. That's looking pretty good. Do I have everything I need? In yellow, I have calcium oxalate. I got calcium fluoride on this side. I have HF, 2 of them, and the oxalic acid. So that does work out. My final reaction when I add them is CaC2O4 plus 2HF in equilibrium with CaF2 plus H2C2O4. Let me slide this up a little bit, and K is going to be equal to K1 times K2 times K3 times K4 times K5 squared times K6 squared. Okay, and so I know all the values for those. I can look them up. K1 is the KSP of calcium oxalate. K2 is 1 over the KSP, so I'll put it down. KSP of calcium fluoride. K3 is KW divided by Ka2 for oxalic acid. K4, that's where I'm up to right now, is KW divided by Ka1 of the oxalic acid. And K5 is equal to the Ka of HF. And I got to square it. And I made a mistake here. I hope you picked it up. These KWs up here should have been 1 over KW. They're both 1 over KW because the water reaction is reversed here. So that will give me KW squared on the bottom. So these cancel, becomes a little simpler. Move this up a little bit. And I get equal the KSP for calcium oxalate, which I've already looked up, is 1.3 times 10 to the minus 8th divided by the KSP of calcium fluoride, 3.2 times 10 to the minus 11th divided by Ka2 is 5.42 times 10 to the minus 5th, and Ka1 for oxalic acid is 5.62 times 10 to the minus 2, and I got Ka for HF squared That's 6.8 times 10 to the minus 4th squared. And I'm good to go. I just got to solve that. The answer is 61.67. Okay, so there's two complicated problems.